All of the good graphics in this slide deck are 100% thanks to Chris Holt, who's sitting right there. All of the bad graphics are thanks to me. So just so you know. Right, thank you all for coming, both to the event and to this talk. I hope you enjoyed lunch. I hope you got some coffee or water or whatever suits your fancy and that you're in a reasonable temperature regulation regime. I am going to talk about the Anoma's roadmap to mainnet, or at least my perspective on this topic. And this talk is a story in 3 parts. In the first part, I'm going to talk a little bit about what Anoma is. Maybe some of this will not be news to some of you, and some of it will be news to some of you, and some of it I'm hoping will be news to all of you. We'll see. Second, I'm going to talk a little bit about what does Anoma mainnet mean, like what do I mean by the word mainnet, which can mean many things. And third, I'm going to talk about how will Anoma be deployed, how will we get to mainnet, what are the phases in between point A, which is now, and point B, which is mainnet. So first, what is Anoma? Here I'm going to talk about 2 entities related to the word Anoma, the Anoma protocol and the Anoma network. The Anoma protocol is a distributed operating system for intent-centric applications. And in the next few slides, I'll go in a little bit more to what I mean by operating system and what it means for an operating system to be distributed. Intent-centric applications, I'm not going to talk about too much in this talk because I'm hoping that you've heard of them already. But if there are some questions there, I will take questions at the end. So feel free to prepare them as we go. The Anoma network is the interlinked graph of computers running this protocol. So these definitions are directly related to each other, right? The protocol is at least a design for a piece of computer software. There could be different implementations of the same protocol, but any computers running an implementation of that protocol and talking to one another, they are part of the network. This graph is not necessarily fully connected, but all of the computers running the protocol are part of it. So, let's go back in time a little bit and ask ourselves the question of what is an operating system? And at least for those folks working on Anoma, we didn't realize initially that Anoma was an operating system. We embarked upon this quest of research and design from the kind of baseline of blockchains, of Bitcoin, of Ethereum, of thinking about intents, thinking about users. We had no experience in operating systems design. But over the years, we've come to the conclusion that really what Anoma is trying to do fits in the broad class of what the research literature understands as operating systems. And an operating system always does 2 things, 2 essential things. One, it abstracts diverse hardware behind a universal interface, so an operating system can run on many different types of hardware, and then for that hardware, or to access that hardware, it provides a universal interface, and that universal interface is provided to applications. So an operating system, the second thing an operating system does is that it provides an environment in which applications can run. So if you think about operating systems today, maybe 3 prominent classes come to mind. The first class of operating systems today are desktop operating systems, such as Windows, or Linux, or Macintosh, macOS. And all of these operating systems fit this definition. The hardware that they abstract are the actual physical computers. So, I guess Pentium chips early on for Windows, all the way up to Xeons, or whatever it is that they run now. Various CPUs, mostly x86, 64-bit CPUs for Linux, and for Mac OS, the same, and now Apple's ARM chips. So they abstract that hardware and provide a universal interface on top of which applications can run. The second class of operating systems that are pretty common today are mobile operating systems, such as iOS, Android. And the third class are web browsers, such as Chrome and Safari. Now, you might not think of web browsers as an operating system, but they fit this definition. Web browsers abstract the hardware of the actual computer, and usually they're running on top of an existing operating system, with an exception of, like, I guess that Google's Chrome laptop project, Chromebook, whatever it was called. But apart from that, they run on top of an existing desktop operating system, and they abstract the abstractions of that hardware provided by the desktop operating system and provide an interface in which web applications can run, right? Websites started as pretty simple things, but over the past few decades, they've developed to basically full-fledged programs which do computations, they need to store state, they need to perform network requests, etc. So web browsers are operating systems. They're just very poorly designed ones. And if we can learn anything from the past few decades, of web browsers and the internet, I would nominate that one thing we should learn is that it's better to design an operating system on purpose than by accident. So we are trying to learn a little bit from that as we can. So Anoma is an operating system in the same basic sense of this definition, but it has one very different component or sort of conceptual feature, which is that it's distributed. So similar to the operating systems I discussed in the last slide, Anoma, specifically similar to web browsers, Anoma runs on top of an existing base-level operating system that abstracts differences in physical hardware. So Anoma itself is not concerned with like compiling code to x86 CPUs. There exist operating systems that do that. That would be not a very useful thing for us to do. And Anoma provides a clean sandbox for applications, a bit similar to something like a web browser. But what's different about Anoma is that Anoma aims to abstract the hardware of many network computers at once. So as opposed to, you may think of a web browser as having to do with the web, and it does, but a web browser is still abstracting the hardware of one machine. You run your web browser on your laptop, it abstracts the storage into local storage, it abstracts the compute into WebAssembly web workers or things like this, right? It's abstracting the hardware of one machine. And it doesn't deal with any of the complexity of dealing with interlinked computers. All of that complexity is actually foisted on the web applications. So Anoma aims to abstract this distributed network of many computers so that applications can treat this network as if it were a single abstract machine, in particular an intent machine. So I want to talk a little bit about what the hardware means in this context. So certainly Anoma is the protocol is a piece of software that you can run on a computer, you can have your laptop, you can have your server, you can download the Anoma code base, it's on GitHub, and you can start running it. So Anoma abstracts that hardware. But Anoma can also abstract blockchains. And what I mean by this is if we think of a chain like, let's say, the Ethereum mainnet. The Ethereum mainnet is a bunch of validators running a consensus algorithm that produce periodic blocks. And in those blocks, the EVM provides interfaces allowing applications running on top of it to store data, to perform computations, etc. So from the perspective of Anoma, the Ethereum network is like a computer. And the fact that it's a computer that can be, in fact, one kind of hardware on top of which this operating system can run. And the fact that that computer is implemented in an operationally decentralized fashion, that there are many validators who replicate the computations and run a consensus algorithm, doesn't matter from the perspective of Anoma, the operating system, because Anoma just sees this kind of state machine, the EVM, and the EVM provides the basic things that any piece of hardware the operating system can support needs to provide. It provides storage and compute and an ordered list of events, stuff like this. So that was part one of the story. Are you following me so far? Okay. Part two. What does Anoma mainnet mean? This word mainnet, mysterious. What do you mean by mainnet? So by mainnet, I mean a version of the Anoma software which allows developers to build and deploy real applications that will carry real value. Like, it's not a testnet. What is real value? That's a philosophical question that is beyond the scope of this talk, but you probably know it when you see it. Anoma mainnet does not mean that any native Anoma token or Anoma consensus will be operational. So this might be a little bit different than some things which have been called mainnets before in the past, but I think it's a mainnet in the most important sense, which is that people can actually use it to do real things, to do real economic coordination in the real world. And Anoma's mainnet uses an architecture, sort of a specific architecture of operating system deployment, as I'll get into, which we are calling minimum viable resource plasma. The word plasma comes from a kind of subdiscipline of Ethereum research that's been around for a long time. I think since the days of sharding in 2016. Someone can correct me on this if I'm horribly wrong. And plasma, in particular, from the Ethereum research context, plasma is demarcated from other scaling strategies like rollups by its attempt to place the data off-chain, right? So plasma is kind of this, in some sense, it's the alternative history, it's the scaling strategy that Ethereum didn't take, right? Ethereum chose to take, for the most part, the scaling strategy of rollups, sometimes called layer 2s, where the Ethereum validators still store, at least temporarily, all of the data in blobs, but sort of sequencing and computation happens elsewhere. And that simplifies the model, but it's less capable of scaling because all of the data still has to be stored by the Ethereum validators. So Anoma is interested in kind of this alternative fork, the research roadmap that Ethereum didn't take, and using that as a sort of way in which we can make this new and hopefully interesting but also very different operating system that we've developed connect to the existing Ethereum network and existing Ethereum liquidity. What does that look like? So in a diagram, in one diagram that I will go through, this is the intent flow of minimum viable resource plasma. And by intent flow, I mean, in Anoma, we always think about our sort of problems of distributed systems design from the perspective of a user who has an intent, or really many users who have many intents. Those users with intents demarcate the boundary of the system, right? They send their intents, in some sense, into the system, and in the context of Anoma, this means quite literally sending them over the peer-to-peer network. They send those intents into the system, and everything after they send those intents into the system is within the domain of our design, which means that we care about having protocols for it, we care about being able to analyze it, we care about being able to clearly describe to users what kinds of properties they can get when they send their intents into the intent machine, into Anoma. So in minimum viable resource plasma, what does this look like? First, I'll start all the way from the right side of this diagram, which is the end of the intent flow. There are existing what I will call settlement layers. And settlement layers are running some kind of distributed or decentralized consensus. And I'm going to focus here on ones in the Ethereum ecosystem, although the architecture itself is general. So this could be, for example, the Optimism mainnet, the Ethereum mainnet, the Arbitrum mainnet. It could even be like your laptop. I don't know who's the guy in the front. You seem like you could run a settlement layer to me. Right, so if you could send your intents to his laptop there, and he could settle them for you, and that would be compatible with this architecture. Would you choose to trust him? No offense, but I don't know. But I want to make it clear that these are just examples. So what we'll do, or what you can do here with minimum viable resource plasma and Anoma, is deploy a particular kind of smart contract that we call a protocol adapter. So a protocol adapter, in the case of EVM chains, is an EVM contract that can basically process Anoma transactions and verify Anoma state changes that happen elsewhere. So anywhere a protocol adapter is deployed, it becomes possible to settle intents, to settle Anoma intents. And this is a little bit, if you're familiar with protocols such as 0x, I hear someone from 0x is in the audience. Yes, hello. 0x or Wyvern or I guess what Seaport, the one OpenSea uses now. It's a little bit similar, but it's of course more capable, designed to support all of the things that Anoma state can do. So those are the settlement layers. Let's go back to the users. The users have intents. And users, in the context of Anoma, we really care about this heterogeneous peer-to-peer network, which means that users might have many different kinds of intents. They might reference state on many different settlement layers. And the job of the peer-to-peer network is to route those intents to the right place, namely places where they can get matched and eventually settled. So there are a bunch of users. Those users send those intents to different peer-to-peer nodes and different solvers. Those solvers do some searching. They search for matches. And ultimately, at the end of the process, when a final balanced, valid transaction is constructed, that transaction can be submitted to the settlement layer. So all of these parties here, you can see in the red boxes, are running Anoma nodes in the resource plasma architecture, which means that they're using the Anoma software, connecting over peer-to-peer, sending intents, performing solving, etc. But when they publish transactions, those transactions are ordered, executed, and kind of state changes are sort of signed and broadcast by these existing settlement layers in the Ethereum ecosystem running protocol adapters. So the big advantage of this, deployment strategy, why I'm excited about it, is that it basically, to users, it brings the benefits of Anoma applications and interoperability with existing liquidity, and to Ethereum, existing Ethereum chains and settlement layers, it brings a new class of applications that are not possible to build on the EVM, right? So Anoma is kind of like, Resource Plasma is a little bit like Ethereum, but not the EVM. Maybe a controversial take in 2024, I don't know. I want to talk a little bit about the difference between resource plasma and plasma. Who here is familiar with plasma? Like read some Ethereum research blog posts? Okay, that's a sizable crowd. So when plasma was articulated by the Ethereum research community, it was focused on what I'll just call a pretty simple operational setup, where there's one, I believe it's called an operator, one operator who stores data and who might often sequence transactions, and who is responsible for usually giving data back to the user. So in the early plasma constructions, the user was responsible for storing their own data. And this has an unfortunate restriction that the user has to be online in order to do a lot of things, right? So a lot of what Anoma provides to the plasma architecture, or so to speak, is the ability to store data in many places and to have intents and transactions ordered by many operators, and to link these things together by a heterogeneous peer-to-peer network and protocols that kind of know where certain pieces of state or data or intent should go when, right? So the Anoma protocol is aware, or so to speak, aware of the semantics, or at least aware of, let's say, what it would take to match a given intent, or who might want to know a piece of data, or who knows a particular piece of data. And this awareness allows it to route around data and intents to where they need to go, which makes plasma plausible from a user experience perspective, right? If as a user you have to go online in order to receive payments or in order to interact with anyone, these distributed systems, particularly intent distributed systems, become less useful. But resource plasma doesn't have this kind of liveness requirement. Right, so to the Ethereum ecosystem, we hope that resource plasma can offer a kind of defragmentation. And what I mean by defragmentation is that Anoma applications, unlike, say, contracts that you deploy to a particular EVM chain, they don't live on a blockchain, right? They also don't live in some imaginary abstract cloud, but Anoma applications have state, and that state, different parts of that state, which we call resources, different parts of that state can move around whenever they want to any settlement layer which has the protocol adapter, right? Including Optimism, Arbitrum, Ethereum, and this guy's laptop. You can move your Anoma state to any of those places. This is, from a user's perspective, this provides a much higher level interface where you don't need to think about things like bridging. Your state, at any given point, it lives on what we call a particular controller. That controller has to authorize updates to it. But you can have state of one application sharded across many places. These can be combined in the UI. You can still control your own trust assumptions when you want to, but you don't need to pay this complexity cost. So it's a bit, it's like, in some sense, it's just a database system where when you interact with PostgreSQL, you don't need to worry about which shard your data is on. Now, of course, what's different in our case is that when you interact with PostgreSQL, you probably need to choose to trust the person who's running the PostgreSQL database. And we give users control over their trust assumptions, or this architecture gives users control over their trust assumptions, but without requiring, they don't have to give up any UX trade-offs. So that's enough, perhaps, about what Mainnet is. What can you do with it? What can operators do? So by operators, I mean different parties in the ecosystem who basically just want to run infrastructure, who want to run nodes, who want to participate in peer-to-peer networks, who want to run solvers. Well, I'll do solver separately, but operators want to run infrastructure. They might want to provide storage services, right? Operators can run Anoma nodes, and they can configure them to engage in network interactions per their specific preferences. So they can configure their nodes to participate in the intent gossip network, to participate in solving, to participate in settlement. And operators can also relay messages between Anoma and Ethereum nodes, including running locally on their physical machine, right, which is pretty low latency. Solvers. Solvers can do the basic thing, which is process Anoma intents and search for matches. They can collect fees or slack or tips as specified by users. And in particular, a benefit of the resource plasma architecture is that it makes Anoma intent liquidity interoperable with all of the existing Ethereum intent liquidity. That is, solvers can combine an Anoma intent and an Ethereum intent, like, let's say, something in the style of CowSwap or OpenSea, in one transaction and settle that atomically on one of these settlement layers. So from the user's perspective, they don't pay a price or pay a price in terms of worse efficiency for using some different non-interoperable pool of liquidity. what can developers do? Developers can write intent-centric applications using the Anoma resource machine, the Anoma state architecture, and Juvix. They can use transparent, succinct, and zero-knowledge proof options, which are choices that can be made independently of the application development. And they can immediately leverage permissionless intent infrastructure, as in, if you write an Anoma application, all of this becomes immediately accessible to you. You don't have to, you can write an application that uses intents, that requires solving, that requires the data be stored in multiple places, that requires a complex peer-to-peer topology, and you yourself do not need to operate any infrastructure. You just express your application in the Anoma format, and you send it to a few of these nodes, and I mean, maybe someone has to pay them, but they can start running it, right? Users. Well, users, first and foremost, can use Anoma applications. And users, especially in the context of this resource plasma architecture, can define their own security model, which means that you as a user can choose service providers for network relay, compute, storage, and ordering or settlement in your intents, and the network will coordinate and enforce these preferences for you. Now, this might sound scary. It might sound like, oh no, I don't want to think about all of these things all the time. But by user, I just mean user or software that's within the user's control. There will still be default configurations and data socialized around and some kinds of feedback mechanisms, say, informing automatic choices made by a wallet. You could compare this to, for example, if you've used MetaMask for several years now, Ethereum has implemented EIP 1559, which is a P controller on gas price for transactions, and your wallet has to figure out what gas price to set, but this is not a huge point of friction, right? There's a feedback mechanism, but the details are, at least most of the time, abstracted from the user. So, part 3, how will Anoma be deployed? 3 phases, devnets, testnets, and mainnet. Devnets. Devnets, which are basically starting now. If you find Michael, where are you? Raise your hand. Find Michael over there this afternoon for a workshop to get yourself familiar with some Anoma applications in Juvix. And I believe the workshop includes also diagrams of the resource model and more cool stuff, which you will find out if you go. What time is that? 15:45 in the workshop room. So DevNets are focused on allowing developers to start building Anoma applications to get a feel for the system and provide some feedback. And these are aimed exclusively at developers. Here be dragons. There will be lots of changes still in the DevNet phase. Much of the protocol design itself is solidified and published in open source research and code, but I'm sure that there will be changes in the exact representation formats as the researchers and engineers get feedback. Testnets, the next phase, are focused on allowing users to start playing with testnet Anoma applications and to provide feedback on UX and functionality aimed at both developers and users. So as a user, you would be able to start playing with Anoma in this phase. And finally, mainnet includes a stable application development interface and full support for the resource plasma architecture, does not include any Anoma-specific token or consensus, and the focus of mainnet is making Anoma applications valuable for users. All right, thank you. And now I will take questions if we have time.
Number two.
Examples. Yeah, you talked about people building applications on top of Anoma. I was wondering if you had any examples of things that people are building or that use cases that you're excited about.
Right, so 3 early Anoma applications that I'm particularly excited about are one, what we call sometimes scale-free kudos, or these are just tokens, but tokens which can be issued and transacted with in a manner which protects users' data, is shielded, and swapped in a manner which protects users' data, and can be sent around this heterogeneous network, which means that you can do things that aren't very easily possible with current blockchains. For example, let's say that you go to an offline ayahuasca retreat for 5 days, something like this, and you want to send some transactions while you're there, but you're not connected to the internet. Using Anoma, you could run a local controller, just running it on the phones of the people who are there, and still do your little payments. I don't know why you're doing payments during an ayahuasca retreat, bad example, but you get the idea with scale-free kudos. The second application is multi-chat. Multi-chat is kind of like a decentralized Discord. So Discord is an app that is very popular in crypto, especially somewhat ironically by DAOs, considering that it's just run by a company in California. And what Discord needs is both a bunch of really cheap data storage and messaging, like you can't send all of your messages in Ethereum transactions, but also complex permissioning. The reason that Discord works, at least I think, for these kinds of very heterogeneous communities is that you can build lots of different channels and permissioning structures which reflect the specific needs of the kind of discourse you want to support. And this is an application that can be built on Anoma. We've built some early prototypes and published research on this topic. The third application is Public Signal. Public Signal is kind of like Kickstarter, but if it were also demand-side driven. So if you go browse Kickstarter, you can see a bunch of projects that someone has decided that they want to start and that they need funding for, but you can only pick from the options available on offer. You can't say, I want this thing that doesn't exist yet, and I would pay for it if only someone would make it, which means both that you don't have as many things to choose from, and that potentially a lot of latent signals don't get surfaced, right? So Public Signal is like supply and demand-side Kickstarter, and you can build with intents on Anoma, and I'm pretty excited about that.
From the perspective of a wallet developer, how would you define a user? Are the accounts also abstracted? How would that work?
How would I define a user? Basically, I define a user as the person in control. So the person in control and any software which is in their domain of control. So my laptop, assuming certain aspects of operating system security, is part of my domain of control. And from the perspective of the Anoma network just gets messages signed by a public key. That's how or signed by a key. That's how they're authenticated. And anything about how those messages were produced is kind of part of the domain of the user. Does that answer your question?
Yeah. So the use of keys is abstracted. You still use a private key, for example?
Right. I see. Anoma itself is not necessarily opinionated about this choice. This would be a choice that is left more up to the application. In the resource model, state is, let's say it's more divided, at least by default, like it's divided into different units called resources, and these different units can have different keys and different control structures. So one way this might manifest from a user's perspective is that you might have some state that's like in your, can be controlled by your main user account and that has pretty stringent authorization requirements, like it requires 2 devices. And then you might have some of your state, a limited amount, $1,000, that you allow to be controlled by your phone. So you can manage those kinds of permissions pretty easily. In that sense, the system is abstract, but yes, there are still keys. Anoma is not providing a service for key management.
All right, thank you.
How would you eliminate the space of applications that preferably are easier to build on the operating system Anoma than anywhere else? Any other alternatives?
That's a good question. So I think, Anoma, building applications on Anoma compared to, let's say, the EVM, provides a few key affordances that aren't provided by the EVM, but it also requires understanding a new system and building new applications from scratch, right? So at least initially, I think that the applications for which Anoma is most valuable are going to be those which benefit from the 2 big new affordances which Anoma offers, which I view as native heterogeneous trust in applications, that you can have state live on multiple domains, and as an application developer, you don't need to manage this, and you can even make how state and resources and control flow around dependent on application semantics. So let's use the example of multi-chat. In multi-chat in Discord, you are changing, in fact, your users are changing the permissions model all of the time, right? The Discord developers define a sort of template, but the users of Discord, the moderators in a particular Discord, are going to define all of the specific permissions. And with multi-chat on Anoma, you can align, let's say, who's storing data and who's ordering transactions for particular channels on Discord with the permissions that are set by the users. And the network will figure out how to route those intents and transactions around. So I think that kind of application, an application like that benefits a lot from Anoma because it really needs this kind of heterogeneous trust architecture. The second bit is information flow control. If you're trying to build a complex application which wants to give users control over which data is disclosed to which parties, but also build that application from a kind of, you don't write circuits with Anoma, right? You write in a high-level functional language, and it gets compiled under the hood to different zero-knowledge backends. If you want that kind of high-level control over what information gets disclosed without, it might not be as optimized as a hand-tuned ZK circuit that the electric coin company can build, but it probably works for most applications, and that you can get with Anoma and the resource machine, but not with the EVM.
How do you imagine users interacting with Anoma apps? Like, is it like you bring in an existing wallet? Is it a single sign-on, or like kind of normal Web 2 flows, or something new?
That's a good question. We haven't figured all of this out yet. I mean, I think that it is possible to make Anoma applications somewhat interoperable. It's possible to make Anoma applications work with Ethereum key formats, which means that your Ethereum keys could be used. To what extent, say, MetaMask can display intents in a way that are legible to the user, that we still have to figure out, and it depends on whether or not they're willing to make some changes on their end as well. I mean, from my perspective, also, this is going to be a long-term, not a short-term answer to your question, but the thing we should aim for is replacing the web browser. Ethereum tried to do this with Mist, and they gave up, and it's very hard, and like browser extensions are a sort of a patchwork solution to this problem, right? But I think it might be worth revisiting that at some point, because this will give users a much more native interface if we can do it well.
I saw like after P2P node, we have solvers, right, in that diagram. So first thing, those solvers are individuals or enterprises? And second, how do you identify like this solver is, like you are choosing this solver to actually execute that intent, right? So how do you identify which solver you want to choose, and how do you identify which solver is like this solver is not malicious, right? And on what properties or on what features you identify which solver you are going to choose for the particular intent?
That's a good question. So if I were to summarize, I would summarize as who are the solvers and how do users choose them and figure out if they're doing a good job. Is that a good summary? Okay, so who are the solvers? Well, they can be anyone. It's permissionless software. So if you are an individual with a laptop, a phone, if you are, I don't know, Deloitte, you can run a solver. That's possible. And you would have a public key with which users can address you and to which they can send intents if they want to give them to you to try to solve. Ultimately, in Anoma, it's always the users making the decisions about where to send their intents. And if users want to make sort of decisions that are in their interest over time, they need to do some amount of monitoring of how solvers are doing. So one way that that happens in our intent model is that intents in Anoma consist always of two parts, of constraints and of preferences. And constraints are enforced by the settlement layer. And they're like 0 or 1, like either I got 5, either I didn't, right? That's a constraint. Whereas preferences are basically like utility functions, like I would like more ETH if possible. And users send those preferences to the solver, so the solvers know what the user's preferences are. Now, nothing forces the solvers to act in accordance with the user's preferences. They can't. They can also do something else. But users over time can measure, they can send their intents to different solvers and measure which solvers are giving me, or more respecting my preferences, right? So users have a kind of feedback mechanism. Over time, and using that feedback mechanism, plus probably some metadata gossip amongst users about which solvers were also good for other users, users can change where they send their intents over time, which ultimately should give them control over the system because they're the ones actually providing the valuable inputs. We published a paper called The Slow Game, which is on the Anoma Research Topics Archive, that digs more into the sort of mathematics behind this regulation, if you're interested. All right. Thank you. Thanks for the excellent questions.